Welcome to Fred
and Amy's Math
Math
Shack.
Hello, today we're going to be continuing our journey in forming and solving quadratics, but this time we're going to have fractions involved. You've got experience in solving equations that have fractions or denominators. One example is this: x divided by 2 equals 5. How do we solve it? Well, we times both sides by 2 technically, which gives us x equals 5 times 2, or 10. Very similar for this one on the right. You might write it as x over 5 equals 0.75 first. It's good practice to get the x on the left-hand side. And then you times through by 5. So 5 times 0.75. Bit trickier to figure that one out, but that one becomes 3.75. Now, what if we wrote the second equation slightly differently? I've got my x over 5, but now instead of 0.75, I write it as 3/4. Well, there's a few things I could do here. I could actually multiply through by we talked about this in the past, by the lowest common multiple of 5 and 4, which is actually 20. So my next line could be 3 over 4 times 20 equals x over 5 times 20. Thing is, when I can sort of change the order that I divide in, so actually I could do 20 divided by 4. And so actually it would become 3 times 5, that it would partially cancel out. And here I could do 20 divided by 5, and that's going to become x times 4. And the thing is, the point I'm trying to make actually is that we can actually go straight from here to here. We can do something called cross multiplying. When we get a fraction, we can basically times the left-hand side by the 5 and get rid of it, and times by the 4 and get rid of it, and it's just, instead of dividing by the 4 here, you times it over here. Instead of dividing by the 5 here, you times it by 5 over here. That can be really effective. Okay, yes, there's nothing wrong with doing this first step, but you can do it a bit quicker. Then we're left, so be aware that the word cross multiply, we're left with 15 equals 4x, and then we would divide through by 4, 15 over 4 equals x, which is 3.75 again. So now that I said that, I want you to have a go at this one. Can you do it using my cross multiplying method, and does it make sense as well? So if we're cross multiplying, hopefully you've had a go. You can do 2 times 4 equals x times 3. I basically times both sides by 4, both sides by 3. When I times the right hand side by 4, it cancels out that one. And when I times the left hand side by 3, it cancels out that one. So I'm left with this. 8 equals 3x. X is going to be 8 divided by 3. Okay, brilliant. Now, a few diagnostic questions. What should be the next line when solving this equation? Is it A, B, C, or D? There's two correct mathematical equations resulting from this one, and that is A and D. We could multiply through by the LCM, which is 21, so this one's okay. Actually, when you do 21 divided by 3, you get 7, and when you do 21 divided by 7, you get 3. And the best thing to do, most efficient thing, is just to do this cross multiplying. So the answer is A. But it's worth being aware that A and D are okay, they're both correct, it's just you've got more to do if you go with D. We can take this shortcut. Let me test you one more time. Now I've got x as a denominator, which should be the next line. Again, it's wait, I was going to say A and D, but it might have swapped around. So cross multiplying is this one, and timesing by the lowest common multiple is that one. It's going to be best to do this one, C, just times through by x, times through by 5, and then we're ready to solve it. So this strategy helps us with quadratic equations that appear as fractions, this might look really horrible when you first look at it. And it's actually, imagine you see this in a month's time, it's not obvious that that is going to become a quadratic. But let's cross multiply. I don't even need to really write it down, I can just do it. So it's going to become x minus 2 is equal to 6 times 4. And I've got rid of the fractions, always a good idea with these sorts of equations. Now we're back to solving, well, we haven't quite turned it into a quadratic yet, but expand that bracket. That's going to be 24. We've talked about how to solve quadratics, get it so it's equal to 0, so minus 24 from both sides. Factorize it. Okay, we'll be looking at other methods in the near future. It's going to be minus 6 and plus 4. So x equals 6 or 4. These steps here I've done quickly because I'm assuming that you've covered the last lesson, that you understand it. So having gone through that one, can you try these questions here? A to E. Similar sorts of ones, get your cross multiplying in, then sort it out, turn it into quadratics that you can factorize. They're all going to factorize. All right, here are the answers. I'm not going to go through these, but you should get that. Try and work out where you went wrong if you don't get those answers. Brilliant. If you did, brilliant for your effort so far. One more example, because we're going to give a context to this sort of scenario. Here are two right-angled triangles, and we're given that tan E is equal to tan F. Find the value of x. You must show you're working. So the key thing here really is to remember what tan represents. And we've got SOHCAHTOA. Tan of an angle, I'm not going to write x because I've got x here. Tan of theta is equal to the opposite over the adjacent. And if I label it, this is the opposite, this is the adjacent, this is the opposite for this one, and this is the adjacent. So we can write down, essentially we can write down what tan E is. It's going to be x minus 2 over x. And I can write down what it is over here. It's going to be 7 over x plus 10. And because they are equal, I can form an equation. And I'm back to what we did in the last exercise. I can now solve it. Cross multiply, got double brackets here, expand them, keep it equal to 7x, minus the 7x, then it's into something that we can factorize, and then we can solve it. Only thing to think about with these geometry questions is, are the solutions valid? And whilst the right hand triangle is valid for x equals minus 5, it's not, the left hand triangle is not. So we would actually reject x equals minus 5 and just take the solution x equals 4. So I want you to do some more practice of this now. Similar sorts of scenarios. Go for it. So in this first one, I've only given two sides of the triangle, so in some ways you can kind of almost guess it, but we've got opposite over hypotenuse here. We're going to create this equation and we're going to solve it. X equals 10. There'll be another solution, but it'll be negative and we'll reject it. And just throwing in cos as well. We get this equation, solve it, x equals 12. Okay, slightly different question. Calculate the value of the gradient of each line if both lines are parallel. This is just bringing in other aspects of maths, so you've got to remember for the gradient it's the rise over the run. So, I've gone straight to the answer there, but it's going to be x plus 7 divided by 2x is equal to 2 over x minus 5. And again, we've created a fractional equation which we can cross multiply, create a quadratic, two answers. What's the gradient? We need to actually substitute back in. So when x is 7, we get a gradient of 1 for both. When x is minus 5, we get minus 0.2. Now, the answers I've gone with here, they say the lines are sloping up, so the gradient must be 1. We actually reject the 1, because if you get a negative gradient, it's going that way. Now, I'm disputing this because there's no actual scale on these axes. It doesn't say that x is actually going up. So I am okay with minus 0.2 as well. But if there were some axes drawn, we need to be a bit careful. I suppose always think about whether the solutions are valid or not. Leave this one as a bit of a grey area. Bringing ratios back in now. Can you figure out how to deal with this one? We've got x squared to x plus 3 equals 4 to 1. Find the possible values of x. I'm going to talk about this one, just like if you're not sure how to start, because I'm going to remind you about a few things. The ratio 4 to 2 is the same as 8 to 4. It's actually the same as 2 to 1 if we simplify it. Now you can think about, what do I times 4 by to give 8? It's 2. And what do I times 2 by to give 4? It's actually 2. How could I work that out? Well, it would be 8 divided by 4, or it would be 4 divided by 2. And those two things are going to be equal. Basically, I can do the left-hand ones divided by each other equals the right-hand ones divided by each other. I can actually do it the other way around as well. 4 over 8 is equal to 2 over 4, because going the other way, I would divide by 2, for example, and that's the same as times it by a half. Another way you could do it, in fact, actually, sorry, I'm just going to show you how does that link in here, because we could do this thing here. X squared divided by 4 must equal x plus 3 divided by 1 for the same reasons as this, and I've created again a fractional equation. Where's the left-hand one come from? Well, actually, there's another relationship going on with the ratio. If I do the left-hand one divided by the right-hand one, it'll be the same as this left-hand one divided by the right-hand one, or vice versa. So I can actually do x squared over x plus 3 equals 4 over 1. Actually, these equations are equivalent. We've just, we'd have to divide by 4 and times by x plus 3, and we'd get this one over here. So it's fine. In the past, we've done ratios. In the sorts of questions we've been looking at, you might have forgotten these. You might not have. But normally, I've sort of taught it using this approach, but it actually doesn't matter. And once you get that, you can solve it just like before, and that's what you'll get. Okay, bit more awkward for sure. Like when you first look at, imagine you first looked at that at the start of today's lesson. It might not have made any sense, but hopefully now, especially since I've explained it, it's coming together. Right, well, let's definitely practice a couple more. So with ratios, what about this one? Once you've remembered kind of the trick, I suppose, it's a bit more straightforward, but make sure you've got this understanding of a ratio, because there's other questions that this is useful in. And this is what we can get. Okay, x is equal to 3, just one value here. We get, technically this is x minus 3 all squared. We just get the single solution. And of course, you could be asked to actually write down what this ratio is. I don't know, just substitute back in. It's going to be 9. 9 to 3. How about this one? Same idea. This is the answer. So well done with your effort on forming and solving quadratics. It's coming together. You can see they just crop up in so many places. That's not that surprising, really, given that so many situations where you can form and solve equations. So of course you can create scenarios where you're going to end up with quadratics. And today you've seen these fractional ones that come out, even though there's some of them, there's quadratic terms already in these equations. But in the earlier ones that we looked at, there weren't. It wasn't quite so clear that they would become quadratics like this one here. But when you cross multiply, you suddenly see that you're going to get this x squared. Brilliant.